This video we will focus on the equation of motion for the case of translation only. Okay. If we recall for form static, we know that if the body is in equilibrium, it satisfies uh, the equilibrium equation that's summation fx equal to 0, summation fy equal to 0, and summation moment at any point has to be equal to 0 also. Okay. So for the case of uh, the body has a motion, if the body have the translation motion, okay, the equation of motion is become summation f is not equal to 0 anymore. It's become equal to ma. That is the acceleration. Now, this is the summation of vector force. This term is the vector force, and it is equal to mass times the acceleration vector at the center of mass. Okay, and this equation can be written in scalar form for the case of planar motion. It decomposes into two equations, that is summation fx equal to ma in x direction and summation fy equal to ma in y direction. And for the case that the body is subject to the moment, it tend to have the rotation also. But if we consider the case of rotational motion, okay, and it's become we have the force applied to the body as shown in the left picture, and the kinetic diagram can be right in the right picture. That is, we assume that it has the acceleration in two direction x and y, and also it has a rotation about c-axis in positive direction, like the right hand side picture. Okay, so for this case, when we summation of the moment about uh, point p, when we taking a moment about point p, we on the left hand side it is the summation of moment come from the resultant force that is produce the moment about point p. Okay, and on the right hand side is we will see that it has, if we consider the moment about point p, the it has the kinetic moments about point p also according to the Fudo force, that is mag. Okay, in both direction, as is we have magx times y and magy times x, that is so also produce the moment about point p also. That is the case of the rotation of the rotational motion. So if we consider the case of if we taking moment about point G at the center of mass in C, so this equation is reduced to summation mg is equal to ig alpha in C. That is it is come from this case that because if the we consider the point of taking moment become point G. So then MAGY and MAGX pass to the center of the point that we taking moment. So then it's not continuous moment, right? Okay, so then we have just only IG alpha. Okay, for the case of when we consider the summation moment about center of mass, okay, we have just only this term. So then for the case that if we consider the rotational motion, we have the equation of motion is composed of three scalar equations like this, that is summation fx equal to magx and summation fy equal to magy. And also we have summation moment about if we consider about point G, that is center of mass, is has actually this term that is IG alpha. But if we consider the summation moment about any point P, okay, so on the right hand side, we is become summation MKP, that is composed of uh, IG alpha and also cross MAG also. That is we have to have the additional moment from pseudo force, that is MAGX and MAGY also. So uh, but this key video we will focus on the translation only. If a rigid body undergo only translation, okay, so it means that it has no rotation. It means alpha is become 0. So if we consider the equation of motion about point G and point G, and point G, that is the center of mass. So we have summation Fx equal to MAGX and summation Fy equal to MAGY. And also we will have summation moment at point G is become 0. It's for this case if we have the translation only. But it has to note that if it makes the problem easier, for the case that the moment equation can be applied about another point instead of the center of mass. For example, if point A is selected to taking a moment, so then we can do it this way. That is, we have the summation of moment about point A equal to MAG times D. Okay, that is the equation of motion for the moment. For this case, that is for the case that we have the translation only. Okay. So if the body is subject to the curvilinear translation, okay, is this best to use an NT coordinate instead? Okay, so for this case, if we apply NT coordinate, we will change the equation of motion in terms of normal and tangential coordinate system. That is, summations of force in normal direction is equal to MAG in normal direction, and summation of force in tangential direction is equal to MAG in tangential direction. And also we keep it like the summation of moment about point G is become 0 because it passed through the center of mass for the case that we taking the moment at the center of mass. But if we do not taking the moment at center of mass, we have to take care of MAGT and MAGN. Okay, time the moment arm of for the case that this is the distance between point D to point G. Also, that is we have to add it. Okay, that is the equation of moment for this case as we're not taking the moment about point G. So let's take a look this example. This example, the hand clasp has a mass of 200 kilograms and the center of mass is located at point G. Okay, and a force of P equal to 50 Newton is applied to the handle. Okay, we will not consider the mass of the wheel, and we would like to find the normal reaction at each of the two wheels at A and B. Okay, and also the acceleration of the cart. Okay, so this is just this case. We consider the cart as the translation, rectilinear translation only. Okay, so this problem is the simple one. As is if we consider the free body diagram and kinetic diagram for the cart. The free body diagram on the left hand side, we have the mass of we have the weight of the cart that is become 1962 Newton. And we would like to find the normal reaction in at both view. Okay, and we have the applied force at the handle is equal to 50 Newton. The angle between the force to the horizontal is 60 degrees. Okay, and for the kinetic equation, we assume that the acceleration, the cart should be moved to the right. So then the acceleration is moved to the moved to the left. Okay, so the acceleration is moved to the left. So then the kinetic diagram is maybe right in this as shown in the right hand side picture. Okay, so then we applying the equation of motion. We starting with the equation of motion in x direction first. So we decompose the force of 50 Newton into x direction. We have 50 cosine 60 degree. Okay, that is equal to magx. Okay, and for this case, we assume that the wheel, both wheel is rolling without slipping. So then we will not consider the friction at the wheel at this moment. Okay, so according to this, we can determine the acceleration of the car easily by solve this equation. We have the acceleration of the car equal to 0.125 meter per second square. Okay, and then we move to the equation of motion in y direction. Okay, and if we consider the equation of motion in y direction, we found that it has no motion in y direction. So then it's become 0 on the right hand side. And the summation of force on the left hand side is equal to A plus NB minus 1962 and minus the components of the force, applied force 50 Newton. It is become minus 50 sine 60 degree. Okay, so we have two unknown. Okay, so then we cannot solve now. We have this equation first. We define it to be equation number 1. Okay, and then we taking a moment about point G in this case. Okay, if we taking a moment about point G, so then it means that MAG is passed to the point of the that we select to taking the moment. MAG will not produce the moment. So then for that case, the kinetic moment is become 0 now. Okay, and we consider the summation of moment of each force about point G. We have 0.3 NA. That is, we assume that counterclockwise is positive and 0.2 NB, right? Okay, and for this case, we know that it is 0.5 meter, 0.5 meter, and this is 0.2. So then the distance is this distance is become 0.3. Okay, so we decompose the components of 50 Newton to horizontal component. We have 50 cosine 60 and times 0.3 now. And we have another components also that is 0.6. 0.6 is come from here. Taking a moment about point G. This is 0.6. Okay, and then times 50 sine 60 degree. So after we manipulate this equation, we have the second one. That is this is the second equation with two unknown also, that is NA and NB. So now we have two equations and two unknown NA and B. We can solve for NA and NB from these two equations. After we solve this equation, we obtain NA is become 765 Newton and NB is become 1240 Newton. This is that's complete this problem.